The topic for today is very simple and sometimes maybe confusing as well. The topic is about prime factorization. What exactly came up in your mind when you first heard about prime factorization? Anyone?
Prime factorization, okay. It means we have to convert all the factor into a prime number for a given number.
Yes, we can
Like
say
that.
that. Yes. Okay, so basically prime
Like
numbers.
36, it will be 2.
Yes, yes.
Yeah, for example, there is a 12, then there will be 2 and 3. 2 will be the prime factor only.
2
Or
square
3.
into 3. Both are prime factors.
Yeah.
Okay.
Yes,
So basically
20.
prime numbers are the building block for positive integers, right? Because prime numbers can't be negative, first thing. There is a fundamental theorem of arithmetic. It states that every positive integer greater than 1 must be either a prime number or any number that can be written in a form of product of prime number, right? So every number greater than 1 is either a prime number or a number that can be written in form of product of prime number. For example, we have 6, 2 into 3, right? I'm assuming that all of you already know about the divisibility rules, which we discussed earlier,
Yes.
because there is highly use of those. Just a quick revisal. For 2, we just see the last digit, whether that is even or odd. For 3, we just add all of the digits and divide by 3. If the result is, if the sum is divisible by 3, the number is divisible by 3. In case of 4, we just see last 2 digits. In case of 5, we see whether last is 0 or 5. In case of 6, we see whether that number is divisible by 3 or 2. So both properties of 2 and 3 are used. In case of 7, we just add double the last digit and subtract from the remaining. If the answer is 0 or multiple of 7, the number is divisible by 7. In case of 8, we just see last 2 digits. In case of 9, we see whether the sum is divisible by 9 or not. And in case of 10, that's very simple. The last digit is 0, right? That's a great reveal. And in case of 11, we just see whether the sum of the odd digits at odd places subtract the sum of the digits at even places if the result is the multiple of 11. In that case, that's divisible by 11, right? No issues for everyone?
No.
Okay. So if let's suppose we have 8. So always start from the least prime number. We have 2. So this is 2 into 4, right? And now 4 is also not a prime number. So again, divide by 2. This is 2 into 2, right? So we have 2 cube. Let's suppose we have 10. And for 10, remember, always take 0 to 2 into 5. Let's suppose you have 100. For each 0, just make 2 into 5. For this 0, make 2 into 5. So prime factorization is 2 square into 5 square. Whenever you see 0, just make 2 into 5, right? Okay, so one more example. For example, we have 24. So least prime number is 2. So 2 into 12. 12 is also not a prime number. So 2 into 6. Now 6 is also not a prime number. So 2 into 3, right? So prime factorization of this is 2 cube into 3, right? Okay. Let's suppose if I ask you how many, for example, if I ask you 10 has how many factors? There are how many factors of 10?
2.
Two.
Sir.
I'm not asking about prime factors. I'm asking about factor. There are difference between factor
Oh.
Four.
and a prime factor.
Four.
No,
Four.
no, no.
No.
Just keep
1,
listen
10,
now.
2,
Listen,
5.
listen. You are saying that 1, 2, 5, and 10.
Oh,
These
negatives
are positive
Negative
factors.
also. Positive.
Remember, they are
Okay.
equal negative factors as well. That is -1, -2, -5, and -10. In ETS guide, they explicitly mentioned that about the positive factors. But in case when they ask about just factors, you must consider positive as well as negative factors as well, right? Okay. So for a smaller number, it is easy to check for factors. That is 1, 2, 5, and 10. For 20, that is also we can find that. But let's suppose if we have a greater number and we have, for example, 1200. Can anyone tell what are total factors of 1200? Or is there any way we can find total factors for 1200? Okay. There is a
For 1,
formula.
0, we can write 2, 5.
Okay. So there's a formula, but before getting into that, we first have to prime factorize this. So as I told you earlier, we can write this as 12 into 100. For each 0, just make 2 into 5, 2 into 5,
60.
and this is 12, right? And prime factorization of 12 is 2, 6, 6 as 2,
3
3,
into 2.
right? So this is 2 cube into 3 into 2 square into 5 square, right? So this is 2 power 5 into 3 into 5 square,
100.
right? Okay. So to find the total factors of any number, not total factor, positive
That
factor.
will be 2 square into 3, no? Like 2 to the power 4.
Oh, yes, sorry.
2 to the power 4, right?
Yes, my fault. Okay. So I'm asking that when you ask to find, I'm just talking about positive factors first, right? For positive factors, there's a formula that first of all, you need to prime factorize the number. And we have 2
Absolutely.
power 4 into 3 into 5 square, right? These are prime factors and these are its power. So just take each power, add 1 in that and multiply those. Add 1 in this, add 1 in this and multiply these. So the result is a total factor of that number, total positive factor of this number. I will repeat that in a generalized term. Let's suppose there is a number n and its prime factorization is a power p, b power q, and c power r, let's suppose, where a, b, and c are prime factors. These are prime factors, and these are powers p, q, r. So total factors, positive factors of this will be just add 1 in the power and multiply those. Right? Now these are positive factors. Likewise, they're equal negative factors as well. So just keep in mind when the question asks about the positive factors or total factors. In case of positive factor, this is answer. But in case of total factor, you will multiply this with 2 to get total factor. Right?
So for negative factors, the same result.
Yeah.
Like
There's equal
Okay.
negative factors.
that's why we multiply with the 2 to get the total
Yes.
factors, right?
Yes. Okay. Now the next thing is about even and odd factors. if I ask you that we have a number 100, and it is how many even factors and how many odd factors? Can anyone tell that?
We have to consider the even value and then do the +1.
For 1 0, we can take it as 2 into 5. And the other
That is if
0,
you're asking about the prime factorization. But am I saying that how many even and how many odd factors of 100 are there?
Okay.
2 odd and 2 even.
No.
6 factors. Sorry, 2 factors.
No.
8.
Listen.
4 odd and 4 even.
Oh, it should be 3. Sorry.
Okay. First prime factorize
9.
is this is 2 into 5 into 2 into 5. So this is 2 square into 5 square. Right? Now for
It will be
finding
9.
the you are saying something?
I was saying the answer would be 9, I guess.
Yes, 9.
You're asking about the total factors.
Total
Those
factor is
will
9.
be
Yes,
Yeah.
total
2 plus
factors
1,
9.
2 plus 1. Those
2
are 9.
plus 1.
Yes, that's
Now,
somewhat,
if
yeah.
we talk about the odd factors,
So odd factor 3
for odd
and even
factor,
factor 6.
for odd factor, just completely
Is 3.
ignore the 2. For odd factor, we consider there is no 2 in that. Just add 1 in the even power, 1 in the power of the odd prime number. We have only one odd prime number, that is 5. Just add 1 in the power, that is 3. So we have only 3 odd factors of this. And for total even factor, just keep the power of 2 intact, that is 2, and just add 1 in the other one. So this is 2 into 3, 6. So total these add up to 9, which is the total factor.
Sir, can you please repeat
Listen,
odd
Can you
factors?
repeat? Can you
So
repeat?
let me give you some other example to do this. For example, we have 1200, right? If you do prime factorization, this is 12 and 2 into 5 square, right? So this is 2 power 4 into 3 into 5 square, right? Okay, so odd factors, for finding odd factor, just completely ignore the 2 value and just add 1 in the other's power and add up and multiply those. For 3, 1 plus 1. For 5,
6.
2 plus 1. This is 2 into 3, 6, right? And for the even factors, just keep the power of 2
And
intact.
10.
That is 4 and 1 plus 1, 2, and this is 2 plus 1, 3. So 4 into 2 into 3, right? So this is 24, and total of these is 30. We can check that by checking the total factors. That will be 4 plus 1 into 1 plus 1 into 2 plus 1. So this is 5 into 2 into 3. Those are also 30, right? I shall explain again. I'm just
I cannot
repeating.
get the
Listen.
even
Odd
factors.
factor.
Listen. For odd factor, completely ignore even, because listen, when the result is even, when we have at least one even integer in that, right? So for that factor, we just completely ignore the even value because there is only one even prime number, that is 2. Just completely ignore the even prime number and just add 1 in the power of the remaining odd prime numbers and multiply those. So that will be 3 for 3, 1 plus 1 for 5, 2 plus 1. This will become 6, right? So no issues with the odd factors.
Yes.
Okay, so for the even factor, just keep the power of the even prime number intact. We have 4, just keep the 4 as it is. Please mute yourself. For even factor, just keep the power of even prime number, that is 2, intact, and just add 1 in the remaining powers and multiply those. So in odd factor, we are just completely ignoring 2, and for even factors, we are just considering same value of the power of the 2 and just multiply the remaining. Got my point? Take one more example.
Yes.
One more example. We have 50, right? So tell how many even and how many odd factors of 50 are there?
One odd and two, two odd and one even.
6 even. 6 even.
Okay,
2 odd. 3 odd.
3 or 3 even.
3 odd,
3 odd.
3 even.
3 or 6
Three odd,
even.
yes, three odd.
Okay, so this is 5 into 2 into 5, and that is 2 power 1 into 5 square. For even, this will be 1 into 2 plus 1, and for odd, this will be 2 plus 1. So 3. There are 3 evens and 3 odd, right? Everyone got this now?
Yes.
Yes, got it.
Okay. Now let's have a very simple question. The question is, which of the following is the possible prime factor of 2 power not 2, 3 power 9 plus 3 power 11 plus 3 power 13? Which of the following is the possible prime factor of 3 power 9 plus 3 power 11 plus 3 power 13? And the options are 3, B is 7, C is 13, D is 91, and E is 3 power 9. I will repeat the question. Which of the following is the possible prime factor of 3 power 9 plus 3 power 11 plus 3 power 13? And the options are, first one is 3, 7, 13, 91, and last one is 3 power 9. We have just 2 minutes to solve this question.
So more than one answer possible?
Yes, this is multiple choice option.
7 and the BC.
Take your time.
BC, A as well.
34.
E is 3 raised to power 9. Is that the option or what is the
Yes.
E value?
This is 3 raised
Okay,
to
then
power 9.
E and D.
So someone is saying E and D, someone is saying B and C, right? So no one will
No, I'm saying ABC. I'm saying ABC.
Okay, okay, BC. Okay, so all of these are options also chosen. Okay. We have this expression, right? We have 3, 9 plus 3, 11 plus 3, 13, right? If we take 3 power 9, 9 common, so this will be 1 plus 3 square plus 3 power 4. Everyone is with me till now?
Yes.
Okay, so we can also write this 1 plus 4 plus, not 4, 9 plus 81. So this is 3 power 9 plus 91.
91.
So someone say that 3 power 9 and 91, both are wrong. First of all, can you tell that 3 power 9 is a prime number?
No.
Because this
No.
is divisible by 3, this is divisible by 3 square, divisible by 3 cube. This is not a prime number, right? 3 is only a prime number, and 91. That's why I asked you earlier to memorize the divisibility rule. Use divisibility of 9 rule here, 7 rule here, because 91, just add 2, double the last one. This is 2 and subtract from remaining. Result is 7. So this number is divisible by 7. So this is not a possible answer. Now just if we proceed further, this is 3 over 9 and this is 7 into 13, right? Okay, Now we have three possible prime numbers. 3, 1 is 3, 1 is 7, and 1 is 13. Right? So 3, 7, and 13 are possible answers. Right?
Right.
Perfect. Now similar question, but with a bit higher difficulty. Now the question is, what is the greatest prime factor of 42 square plus 75 square plus 6300? This is a very input question. I will repeat the question. What is the greatest prime factor of 42 square plus 75 square plus 6300? This is a very good question and it tests several properties. Okay, just take 2 minutes to solve this question.
Thirteen.
So we have one answer, 13. Okay, any other answer?
Seven.
Okay, one more answer, 7. Anyone who is still trying?
21. Sorry. 20.
21 is not a prime number.
Seven.
7.
Okay. So there are a lot for 7. Okay, this is a very good question. Okay, the question is that we have 42 square plus 75 square plus 6300. Okay, first perform the prime factorization of this. We have 42, and what is the prime factorization of 42?
7 into 6.
7 into 3 into 2.
2 into 3 into 7, right? And we have square of that.
Yes.
And for 75, we have
3 into 5 into 5.
3 into 5 into 5, square of that. And for 63, first completely
7
take
into 2. So
that will
3.
be 5 square. For each 0, just take 2 into 5. And for 63, that will be 7 into 3 square, 7 into
3
9,
into 3.
right?
12.
So we have 2 square, 3 square, 7 square, plus 3 square, 5 power 4, plus we have 2 square, 5 square, and 3 square, and 7, right? Now see what is common in all of these. 3 square, 3 square, and 3 square. Please mute yourself, otherwise I will mute all of you. Okay. We have 3 square, so this will be 2 square into 7 square. This will be 3 square into 5 square. Sorry, not 5 square. This is 5, 4, and this will be 2 square 5 square into 7, right? Okay, so how you proceed from this forward?
This is basically a plus b whole square.
Yes,
inside.
exactly. This is 14 square. This is 25 square. And this is 2 into 14 into 25. This is a square. This is b square. And this is 2 into a into b, right? So this is the formula of a plus b square. Okay, so everyone got this, how I come up with this formula?
Yes.
Okay, we have 3 square into 14 plus 25 square now, right? This is 3 square and this is 39 square. And if this will be 3 square into 3 into 13 square, right? Now we have only two prime factors. One is 13 and one is 3. So greatest one will be 13. Right? This is a very good question because it has certain
Yes.
properties. One about the algebraic identities and other is about the prime factors. Right?
So we have to simplify it to
Yes.
till the end.
Yes.
Okay.
The ideal
So
way is
another way would have been that it can be directly written as 42 plus 75 whole square in the first line. 2 into 42 into 75 is 300.
but that will
could
be yes, you can do that.
Yeah, you could have just not do the middle steps.
How are you saying? Sorry.
So in the second line, it is 2 into 3 into 7 whole square
Right.
plus 5 into 5 whole square.
Yes, you can also do that way.
Yeah.
Okay. So this was about just about the prime factors. And now we will just move to the next topic. And that is a very good topic. And that was about the rule of counting. For example, if the question was such that number of integers, if the question asks you what are total number of integers from 8 from let's suppose 10 to 20, what is this? And if the question says that what is the total number of integers from 10 through 20, okay, there could be two more scenarios. If the question says what is the total number of integers, what are total number of integers between 10 and 20, and the last scenario could be what are the total number of integers between 10 and 20 inclusive. So what is the difference between all of these cases? I just wrote down 4 cases, right? The first case was what is the number of integers from 10 to 20? What are total? Notice are from 10 to 20. Other is from 10 through 20. The next one is between 10 and 20. And the last one is between 10 and 20 inclusive. Okay, let's first come up with the generic cases. Then
For the third, we do not count between 10 and 20, but for the fourth one, we will include 10 and 20
yes.
in it.
Okay, so let's see all of these 4 cases separately. Let's suppose we have a set in which a is the smallest integer. and b is the largest integer. In the first case was number of integers from a to b, right? In that case, the answer will be just b minus a plus 1. Why we are adding 1? Because if we just take b minus a, we are ignoring one of these. Let's suppose, for example, if I ask you that number of integers from 3 to 1, if you just take 3 minus 1, the answer is 2. But in actual, there are 3 integers, right? That's why you add 1, right? This is first scenario. The second
3 minus
scenario,
1 is the range.
3 minus 1.
3 minus 1 is the range. Is the
3
range.
minus 1 is a
range
range.
of the
Range is
integer.
different thing. Range is different thing. Whenever you
Yes,
got
range
from
is
A
different.
to B, just subtract bigger one from smaller one and just add 1 in that. Now there was second case, number of integers from A through B. This is exactly the same case. That will be B minus A plus 1. Through, in actual, through mean inclusive. Through is second name for inclusive. It's mean we are including B and A, both of these. So there is no difference between first and second case. Now there was third case, number of integers between A and B. This case is a bit different. That will be B minus A minus 1. Now what this mean? Again, if I take the case 1, 2, and 3, if I subtract 3 minus 1, the answer is 2. But the question is saying between A and B. Between 3 and 1, there is only one integer. That's why I subtract minus 1 from this. Right? And there is one last scenario.
Yes. Yes.
In which number of integers between A and B inclusive. This is exactly the same case as the first two cases, because the term is again inclusive. So we have to consider both A and B as well, right? So this is B minus A plus 1, right? So first, second, and last case are exactly same cases with separate with a different notation, but third one is different. Okay, so everyone got this?
Yes.
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 Because these are highly used terms, especially this through term. Through term is highly used in exam. They could be exclusive as well. Let's suppose if the question asks that from A to B exclusive. Now this scenario has exactly
We'll
the same
use
meaning as the
for
third scenario,
third.
right? So we are not considering B and A, both of these, right? Okay. So now let's have a very simple question. The question is, for example, if the question asks that how many even integers between 17 and 27. And yes, unfortunately, again, the session is about to end. Just again, join the session again from the same link. We will proceed from where we left.